Chrysler Corporation's new sport utility vehicles bring an added dimension to everyday servicing operations. Although similar, the Plymouth Trail Duster and the Dodge Ramcharger are unique compared to other models. However, they differ from the others mainly in the chassis and driveline, so we'll concentrate our story in those areas. The chassis is based on a ladder-type frame with full-length, open-channel side rails connected by 7 cross-members. The body is attached to the frame at 10 rubber-insulated mounting points. Drive axles are used front and rear, with conventional leaf spring suspension and a front stabilizer bar. Standard or optional heavy-duty shock absorbers dampen spring action for ride control. The front springs have 3 leaves each and mount directly on spring pads welded to the axle shaft tubes. The springs are rubber mounted both at their front ends and in shackles at the rear ends. These rubber mountings do not require lubrication. The front axle drive gear housing and propeller shaft are off-center to clear the engine. The drive gear section is of conventional design, except that it has internal axle shaft oil seals at the differential side bearings. The front propeller shaft has a single open cross universal joint at the axle end with a conventional lube fitting for the slip joint. A 2-cross constant velocity joint is used at the transfer case end. This joint has a recessed lube fitting for the ball and socket. The front axle is equipped with ball pivoted steering knuckles and open universal joint type axle shafts. The factory lubricated ball joints do not have lube fittings. However, the axle shaft universals can be taken apart for inspection, seal replacement, and lubrication when the shafts are removed from the axle. At the front, the steering knuckle arms are connected by an adjustable tubular tie rod. Note that the solid one-piece drag link has a short offset section at the rear end, which, if installed at the front, will cause steering interference. The tie rod and drag link ends have conventional lube fittings. Now, as we move to the rear of the chassis, we see that the rear springs have 4 leaves each, but are mounted with spacer blocks between the springs and axle pads. Both spring ends are rubber mounted and therefore do not require lubrication. The rear axle is a conventional type with the drive gear housing centered on the engine crankshaft line. The propeller shaft has a single open cross universal joint at each end, with lube fittings at the universals and the slip joint. Both axle propeller shafts are driven from a transfer case attached to the output end of the transmission. Power flow is direct through the transfer gear train to the rear axle and is transferred to the front axle through a chain drive and separate output shaft. When the transfer case selector is in any position except neutral, the transfer gears provide full-time 4-wheel drive to both axles. Unlike vehicles with locking front wheel hubs, the front wheels here cannot be separately disconnected from the powertrain for freewheeling. With this drive system, an interaxle differential in the transfer gear train adjusts the power delivered to both axles to keep the front drive components from overspeeding when the vehicle is driven on dry, hard-surfaced roads. This differential can be locked out to provide equal power to both axles for more demanding off-road operation. Moving the transfer case selector to high or high lock position engages the gear train in direct 1-to-1 drive. In low or low lock position, you get a 2-to-1 reduction from transmission output shaft speed. Neutral, of course, disengages both axles. To shift between low and high in either direction, the vehicle must be stopped. First, shift the transmission to neutral. Then, move the transfer case selector to neutral and shift it to the desired position. You can shift from high to high lock or from low to low lock while the vehicle is moving. Now, returning to the front axle, we find that the live spindle part of each axle shaft extends through the steering knuckle to engage the splines in the brake rotor hub. The hub bearings in the knuckle are retained by a plate bolted to the knuckle. The axle shaft seal is in the knuckle. The bearing seal is in the retainer plate. Unlike conventional non-driving disc brake rotor and hub assemblies, a special tool and adapter set must be used to remove and install the bearings without damage. You'll also need a puller to remove the rotor and hub assembly. When removing the rotor and hub assembly, it's best to loosen the axle shaft nut and the wheel attaching nuts before raising the vehicle. And since we're going to remove the brake caliper, the brake pedal should be blocked up so nothing can happen to force the piston out while the caliper is off the adapter. After the caliper is slid off the rotor, set it up out of the way. Do not let the heavy caliper dangle on the hydraulic hose. Now, through the access hole in the rotor hub flange, remove the 6 cap screws which hold the bearing retainer plate in place. Back out the screws carefully so they will remain with the socket when it is withdrawn. Remove the axle shaft nut and install the puller tool on the hub flange studs. Pull off the rotor, hub, and bearing assembly and remove the tool. Be sure to remove the retainer plate O-ring seal from the steering knuckle. To inspect and repack the bearings, the rotor must be disassembled. Hold the assembly firmly in a vise to make the job easier. Set up the bearing remover tool and pull the inner bearing cup and cone, spacer, outer cup, and retainer plate from the rotor hub as an assembly. Next, reposition the special tool and add the necessary adapters to remove the outer bearing cone remaining on the hub. Then remove and discard the bearing seal. Since both bearings are the same size, be sure to keep the respective cups and cones together. To reassemble the rotor hub and bearings after cleaning and inspection, again clamp the rotor hub assembly in the vise. Install a new bearing seal flush with the outer face of the retainer plate. And locate the plate on the rotor hub. With both bearings re-lubricated, position the outer bearing cone on the hub. Next, with the special tool set up for bearing installation, press the cone on until it bottoms. Then remove the tool head for the next step. Place the grease-coated outer bearing cup over the outer bearing cone on the hub and add the spacer. Next, add the grease-coated inner bearing cup and press on the inner cone with the special tool. Remove the tool and the rotor is ready to install. If the axle shaft is to be removed for any reason, use a hammer and punch to tap out the axle shaft seal from the steering knuckle, working around the shaft circumference from the outside. With the seal removed, carefully slide the outer and inner axle shaft assembly out of the axle tube. To replace the axle shaft, slide it into the axle tube. Align the inner splines and bottom the shaft, being careful not to damage the internal oil seal. Install a new seal in the knuckle using the installing tool. Install a new O-ring on the knuckle, and we're ready for the rotor. Carefully slide the rotor and bearing assembly onto the axle shaft splines and work the bearing assembly into the knuckle. Install the axle shaft nut, but do not tighten it at this point. Through the access hole in the rotor hub flange, align the bearing retainer screw holes with those in the steering knuckle flange. Install the cap screws, tightening them to 30 foot-pounds in a crisscross pattern to pull the assembly evenly into the steering knuckle. With the transmission in park to lock the rotor, tighten the axle shaft nut a minimum of 100 foot-pounds. Continue tightening until the next slot in the nut aligns with the cotter pin hole and install the pin. Slide the brake caliper in place on the adapter, making sure that the caliper is properly aligned and seated. Install the anti-rattle springs and retaining clips and torque the attaching screws to 200 inch-pounds. Now, before we finish our story, let's hit the high points of wheel alignment. Wheel camber, which is not adjustable, should be checked before the caster setting. The acceptable camber on both sides of the axle is positive 1 1/2 degrees. The positive caster angle should be 3 degrees on both sides. If the setting is not correct, it can be adjusted by installing wedge plates between the springs and the axle mounting pads, with the thick part toward the front to decrease, or toward the rear to increase the positive caster. Toe-in should measure between 0 and 1/8 of an inch, with 0 preferred, and can be adjusted by increasing or decreasing the length of the steering arm tie rod assembly. And a final front-end note before we close this session. Be sure to inspect the drag link and tie rod seals regularly. Immediate replacement is recommended if they're cracked, torn, or otherwise damaged. And use the correct pullers when disconnecting tie rod or drag link ends to prevent damage. There are many other facts and details about these new vehicles which you'll find in your service manuals, so give them and your reference books a good going over. Our next session gives the inside story on 1975 model emission controls and should be of interest to everyone, including owners and new vehicle prospects.